there. Today we're going to look at compound inequalities. We have looked at solving one-step and multi-step inequalities, and now we're going to look at compound inequalities. All right. What a compound inequality is an inequality that is formed by joining two inequalities with the word and or the word or. Now sometimes on an and inequality we don't actually use the word and. So let's take a look at what we're talking about. On a compound inequality with the word and, sometimes we're going to see it written like this, with just the variable in the middle and numbers on either side with inequality symbols. That is an and inequality. Anytime you have a compound inequality that is an and, when you shade it on a graph, you're going to have two endpoints and you're going to shade in the middle. So let's set up a number line with our two numbers from our inequality, and let's graph each one of these separately. So the first one is -3 is less than x. Maybe it is, if I can get it right in here. Okay, but we're going to rewrite this with our x on the left side. So I'm going to turn the whole thing over. I'm going to put the x on the left, the -3 on the right. Now it was eating the x in the original inequality, so it still has to eat the x. So that's why it is x is greater than -3. So that is going to be an open circle shaded to the right. So I'm not going to go all the way though. I'm just going to go a little ways there. Now I'm going to shade the next inequality, which is x is less than 2. Okay, again, that's an open circle, but this time I'm going to shade to the left. And when I connect those two shadings, I have two endpoints and everything shaded in between. That is a compound inequality with and. Now, compound inequalities with or will always have the word or in them. So I've got an example here, x is less than -3 or x is greater than 2. And anytime you have a compound inequality with or, when you graph it, what you end up with is two endpoints and they're shaded in opposite directions. So let's take a look at this one. Let's set up our number line with our two numbers. And let's graph our first one, x is less than -3. Open circle, going to the left. Let's shade our next one, x is greater than 2. Open circle, going to the right. Notice that I have two endpoints and they're going out. That is a compound inequality with or. So let's use some examples. A number x is greater than -8 and less than or equal to 4. Well, let's write our first one. X is greater than -8. Then we have another one that x is less than or equal to 4. Now we know that this is an and. So if we're going to write this, we know that our x goes in the middle and our two numbers go on either side of it. So our smaller number is -8 and our larger number is 4. Now all we have to do is put our inequality symbols. Now notice on the first one, x is greater than -8. The inequality is eating the x. So when I write it in my and statement, it still has to eat the x. Okay, on the next one, x is less than or equal to 4. It's pointing toward the x, so it still has to point toward the x. And if I'm going to graph this, I'm going to put both of my numbers on my number line. I'm going to put an open circle by the -8 and a closed circle by the 4, and then I'm going to shade everything in between. Okay, now a number y is at most 0 or at least 2. Now this is an or. So I can write two separate inequalities with the word or. Let's write our first one. Y is at most 0. At most, that means 0 is my top number. So y has to be everything that's less than that. So y is less than or equal to 0. Or at least 2. So 2 is my bottom number. So y has to be everything that's greater than or equal to that. So y is greater than or equal to 2, and that is an OR. So to graph this, I'm going to set up my number line with my two numbers. And let's graph our first one. Y is less than or equal to 0. That would be a closed circle, shaded to the left. My next one, y is greater than or equal to 2, would be a closed circle, shaded to the right. And this looks exactly like we would expect an OR inequality to be graphed. Now, I would actually like you to try these two on your own. So pause your video now and then come back and look at how I do it. All right, now that you've had a chance to try this on your own, on this first one, this is an AND, so we know we're going to have 2 points and it's shaded in between. So our 2 points would be -4 and 3. And it looks to me like they're both going to be open circles, and we're going to shade in between. The second one is an OR, so I know I'm going to have 2 points and it's shading out. So let's put our 2 points on our graph. And the first one is going to be an open circle shaded to the left. And the second one's going to be an open circle shaded to the right. Now, is 6, the number 6, a solution to the compound inequality 3 is less than x is less than 24? Well, how you do this is you just replace the x with your number. So I'm going to say 3 is less than 6. 6 is less than 24. Is that a true statement? It is. It's true. So yes, 6 is a solution to this compound inequality. If that was not a true statement, then it would be no. Write an inequality that fits the graph shown. And well, my first one is an OR because I have 2 points shaded out. So first thing I'm going to do is I'm going to write OR. And then I'm going to write one equality on the left and one on the right. Let's write our first inequality. Well, it looks like the number is 3, so x, and it's an open circle, so x is less than 3. And the one on the right, it looks like it is at 5. It's an open circle, so x is greater than 5. Write an inequality that fits the graph shown. All right, so this is 2 points shaded in between, so this has got to be an AND, so we know that our x is going to go in the middle, and we're going to have 2 numbers on either side. Well, our 2 numbers are -2 and 2. So we know that x is greater than -2 or equal to, because it's shaded in, and we know that it has to be less than or equal to 2. All right. Now, if you have questions, make sure that you are talking to your teacher. And again, I can't figure out. Sorry.